Hello, I'm here to talk about crawlerugo, a Python package that helps you crawl folders recursively, and you can even determine the depth at which you want to crawl by actually indicating the max depth parameter. And if you ignore the max depth parameter, it's going to crawl the whole folder to the last of it. And you can as well pass in a function as a parameter that can perform certain operations while you're crawling. First of all, we are going to start by importing the Python package. It's called pip install crawlerugo. That's the package. Pip install crawlerugo. I think I've already installed it before, so it's going to come back in as requirement already satisfied. It's there on the screen. Requirement is already satisfied, so we just have to carry on then. Let me start the application. It's actually a Flask application that's running on port 8000. So let me import the package from crawlerugo dot crawler import crawl. That's the function. Let's say result equals to crawl, and we'll need a base directory to crawl. So equals to os dot path dot dir name brackets os dot path dot apps path brackets. I'm dealing with current file. So we're getting the current directory where the file running is. This is just for demonstrating purposes. So base directory, this base directory, comma, and then I'll pass in a lambda x return x just for demonstrative purposes. And for the third parameter, I'll put none. If I put 2 here as the value, it's just going to crawl into the depth of 2. That would be 0, 1 by based on the depth of the recursiveness of the folder. So let me just pass this as a parameter results. Okay, I'll print the results on the console as well, because I know I'm not going to format it perfectly on the web page. We have a web page, home.html. Actually, I'm looking for results and I'm just displaying it. I'm just displaying it basically. That will be below welcome to Project Flask API blueprint. So we are looking for results. That's a parameter. And going back to our Python file, it's supposed to be results, not plural. Okay, application has stopped. Let's relaunch. Our application has started. It's running now, and let's check the browser. I know it's still setting up. It's a little bit slow as I have some background processes that are already running on my system. Okay, that was an old loading. I'll need to refresh it. It's basically going to display this as I've run it before. I think the Flask application is still starting. That's why I'm having some slower load time with other background processes that are running on my system. Sorry for the. I guess the application has not yet started. It failed. Oh, there's a mistake in the port. It's crawler. It's from crawlerugo.crawler. I did a mistake. Yeah. Relaunch the application and it's starting. Listening at port 127.00.18000. So everything is setting up. And let's refresh. Let's refresh this. There's an error. Well, for demonstrating purposes, let's just take a look at the console. Let's take a look at the console. So I'm running the application from the browser. I'm not displaying the result here on the browser. I'm going to look at it at the console. The application is booting. Uh, it's a bit slow. Okay. Basically, that's the response on the browser. It has printed out the a list of objects. You can see we have name, web, stats, none. That means it's a folder. Callable data, nothing was returned from the function that was passed in the lambda. The next is init .init.py file. We have a stat, which is a POSIX part object which contains more information. And the callable data is actually what was returned is the name of the file, because the lambda was returning the name of the file. So for these POSIX stats, you can get the size of the of the file by actually passing this JSON and getting these objects, and you can get the size of the file based on whatever you want to do with the application. So that ends my presentation. Thank you.